Today's lesson is about using the inverse norm feature of the TI 8384 to find z-scores of the standard normal distribution, or x-values or horizontal axis values of the normal distribution. Let's begin with an example where we have the standard normal distribution in which mu equals 0 and our standard deviation sigma equals 1. And we want to find z so that 5% of the area under the curve lies to the left of z. Okay, so we are finding z. And it helps to draw a picture, so let's draw a little picture. We want to find this z so that the area to the left is 0.05. Okay, this is actually quite simple. Let's see how we do it. Our calculator is on. We press second and then the VARS button to get to the distributions, and we will select number 3, inverse norm. We want our area to the left to be 0.05. Okay, and then our mean is 0. Our standard deviation is 1. Enter, and we see negative 1.645. Okay, so our z then, our z equals negative 1.645. All right. Let's do another example which is quite similar, only in this example we want to find z, and again in the standard normal distribution, mu equals 0, sigma equals 1. Let's find z so that the area to the right of the z under the standard normal curve is 0.01. So there's our z, and this area is 0.01. Okay, well, we will still use the inverse norm feature, but this time let's observe then that our area to the left is actually 0.99, and we will use that number in our calculations. So again, second, inverse norm, area to the left, 0.99, and then again mu is 0, sigma is 1, and we get, rounding to 2 decimal places, that our z equals 2.33. All right, let's do one more example. And in this case, we're not going to use the standard normal distribution. We're going to use a different ordinary normal distribution. So in fact, we're going to say we are given a distribution of grades. And we're going to say that our mean is 76 and our standard deviation is 8. And furthermore, we're going to say that we have 8% of the grades are A, 8% are F, and we'll have some other constraints. What we really want to know is how many, or rather, what are the cutoff scores for the grades of C. So let me fill in this picture with some information that we're going to have. It's given for you that we have the middle distribution of the C's. Let's say here's our 76. We're given that 44% of the grades lie in the middle. And I'm going to call this X1. I'm going to call this X2. X1 represents the boundary between the D's and the C's. X2 represents the boundary between the C's and the B's. Okay. We are given that 8% of the grades will be A's and F's, and then the next 20% will, on either side, will be D's and B's. So we are given that the area here is 0.20 plus 0.8, and likewise the area here is 0.20 plus 0.08, 0.20 plus 0.08 in both cases. So this adds up to 1, and all we want to do now is find our X1 and our X2. So keeping in mind that the inverse norm feature finds z values or x values given an area to the left, we can easily find the area to the left of x1 is 0.28, and then we can easily find x1. Let's do that first. All right. All right, inverse norm. We want the area to the left of x1 to be 0.28. Our mean is 76. Our standard deviation is 8. And we find that x1 is about 71. Okay, so x1 equals 71. Now we want to find x2. Well, what is the area to the left of x2? Okay. Adding up 0.44 and 0.28, we get 0.72. So let's go here. Inverse norm. Our area then is 0.72. Mean is the same, standard deviation is the same as before, and we get about 81. Alright, so the boundary between the D's and the C's is 71. The boundary between the C's and the B's is 81.